Suppose that g is a function which has continuous derivatives, which means the first derivative exists, the second derivative exists, the third derivative exists, etc., and that g of 2 equals 3, g prime of 2 equals negative 4, g double prime of 2 equals 7, the third derivative at x equals 2 equals negative 5. Write the Taylor polynomial of degree 3 for g, function g centered at 2. Well, since we're doing a Taylor polynomial for function g, I know that I need g, g prime, g double prime, and the third derivative of g because I'm going to the degree 3. Now, they're all centered at 2, so I need g of 2, g prime of 2, g double prime of 2, and the third derivative of 2. Now, normally, what you would do if you're actually asked for this is you'd be given some function g and you would take the derivatives and then you would evaluate each of these at x equals 2. Well, in this problem, they gave them to us, so I'm going to write them out just like we would normally. We're just skipping a step. Instead of actually having to take the derivative and then evaluate, they actually tell you what you would get. So g of 2 equals 3, g prime of 2 equals negative 4, the second derivative equals 7, and the third derivative equals negative 5. So I would follow the same pattern that I would normally. I would have g of 2 is 3 times x minus where it's centered, which is 2, to the 0th over 0 factorial, plus my next coefficient would have a negative 4, x minus 2 to the first over 1 factorial, plus a 7 from this, x minus 2 to the third over 3 factorial, minus 5, or plus a negative 5, x minus 2 to the third, this was second, I'm sorry, over 2 factorial, and this is to the third over 3 factorial. And then I'm going to simplify this a little bit. So I would say the Taylor polynomial, the polynomial of degree 3 of x would equal, now anything to the 0th power is 1, 0 factorial is 1, so this is just a 3, minus 4 times x minus 2, and then 1 factorial is 1, plus 2 factorial is 2 times 1, so 2, 7 halves, x minus 2 to the third, squared, minus, this is 3 factorial, which is 6, 3 times 2 times 1, minus 5 sixths, x minus 2 to the third. So this is a way to look at Taylor polynomials numerically where you're not actually taking the derivatives and evaluating them, they're given to you.